Alright class, so in this lesson we're going to be learning about area of triangles, of non-right triangles. Before we begin, let's just do a little bit of review of law of cosines. In this problem we're going to look at it in terms of the bearing type problems. Right here in number 7 it says town T is 8 kilometers northeast of village V. When it says northeast, what this is implying is since it's N and E, it's straight down the middle, so we're actually talking about north 45 degrees east. Okay, so let's go ahead and draw this in. Town T is 8 kilometers northeast of village V, so if this is T, then that means that village V would be over here. So it's 45 northeast of village V, so this will give us a 45-degree angle, like that. City C is, this is 8 kilometers by the way. City C is 4 kilometers from T on a bearing of 150 degrees from T. So 150 degrees will mean we go 90 plus another 60 right there. That'll be 150 degrees. And therefore we'll have a remainder of 30 degrees. So this is going to be city C here. Okay, and it's 4 kilometers away. So actually it's not as long. I drew this way too long. I'm going to erase some of this and redraw it so it's shorter, like this. Okay, and then this is city C. What is the bearing and distance of C from V? So what we're looking for is this piece right there. Okay, so you can see here what we've drawn is a triangle. And so to find the bearing and distance of C from V, our main focus is from here. Okay, so let's label the things we know. Notice here in this triangle, if this was 45 degrees, then based off of alternate interior angles, this is also 45 degrees, meaning that the entire angle here would be 75 degrees. In addition to that, we also know that, or don't know rather, we don't know what this angle is in the very corner. We know that altogether this is going to give us 45 degrees right here, but we don't know what this little angle is here. Okay, so based off of this, let's see what else we got. We know that this is 4, and we know that this is 8. So based off of the information given, it looks like we could actually find the distance. Let's go ahead and solve for x. And we solve for x by doing the law of cosines. So x squared is equal to 4 squared plus 8 squared minus 2 times 4 times 8 times cosine of 75 degrees. We just enter that into our calculator now. 4 squared plus 8 squared minus 2 times 4 times 8 times cosine of 75 degrees. And then don't forget to square root that. And it looks like we have a distance of 7.96. So we're talking about a distance of 7.96 kilometers away. That's going to be our one of our answers there. After we get that, we do need to find the angle here. So let's go ahead and calculate that by doing law of sines. So we have sine of 75 degrees over 7.96, our newly found answer, equals sine of whatever we're looking for, that's the angle theta that we're looking for, over the value of 4. So it looks like we can just bring the 4 over and then be able to solve for theta. So 4 divided by our answer and multiply that by sine of 75. And then we're going to arc sine that to get our final angle measurement of 29.02 degrees basically. Now keep in mind that this theta is what's 29.02, but that's not actually what our bearing is. The bearing, remember, is measuring from the north and working its way towards what the angle is that you want. Well, keep in mind what we have here is the 45 degrees, and so we're taking 45 and adding that to 29.02. So if we add 45, we're going to get that the actual bearing is north 74.02 degrees east. That's going to be our true bearing. Okay? Alright, so that concludes the law of cosines problems. Just a little bit of review. We're going to save number 8 for a little bit longer, because this one's actually looking for area. So it's going to be a little bit more tricky. let's actually get into the area type problems and understand how we can find the area of non-right triangles. Alright, we're only going to cover a few of these examples here. We don't need to do all of them because not all of them really relate to area. You can try this first problem on your own. It's just a good exercise to practice your law of sines, your law of cosines, things like that. Okay, so just try that on your own. Let's see here. By the way, if you do want the answer, you should get that h is, I believe, 28.85. So, after you solve all this, see if you can get that number there. Okay? Alright, let's go into number 2. So, or rather, number 3. Find two expressions for the height h from vertex C. So here's vertex C. Let's drop the h down and give it a value, height, h. And we discussed already that if you want to find the height, you can actually use trig ratios to say that the sine of A is equal to opposite over hypotenuse. So sine of A equals h over b. Well, in that case, h is b sine A. Likewise, since we want to find two expressions, we can say sine of b is equal to opposite h over hypotenuse A. So h is a sine b as well. Well, if we want to find the area of a triangle, we know area is half base times height. In this case, when we look at our triangle, the base is the bottom, which is the value of C. And what's the height? Well, we just found that. That was b sine A. That's the area of your triangle. But wait, you say, we have another h. Well, if area equals half base times height, then we can also say that the area of the equation is also represented by half. The base is, again, C, times the height, but this time the height is a new value, which was a sine b. And so you actually get two different equations for the area, and they actually give you the same value because trig ratios, they all work the same. Okay, so we have two equations for area. You'll notice that the area, if you look at the letters, and if you want to find a pattern here, you can actually create a third equation. You'll notice that you basically use two letters. In this case, we use C and B. In this case, we use C and A. So why don't we make a new case? Why don't we use A and B? Now, if you use the two sides, just keep in mind that you also multiply that by sine of the other angle. So notice that you use each letter one time, C, B, and A. C, A, and B. So this is A, B, and sine C. So we have a third area equation as well. Okay. The main idea is that when you want to find area of a triangle, keep in mind that you're multiplying half times the base. Just do the bottom side and also multiply it by a side length times sine of the given angle. Link those two things together. Or side length times sine of the given angle. Link those things together. Okay? That's the main idea behind area. Let's take a look at our next page. Let's go ahead and apply that same concept in finding the area of these triangles. You know that area of a triangle would be half base times height, but, we don't know what the height is. But we do know that with trig ratios, sine of 30 is h over 8, or h is 8 sine 30. Remember, we're just saying take the side with the included angle, that's going to give you the height. So area equals half times the base. Base is 12 times 8 sine 30. Oops, 8 sine 30 degrees. Sine of 30, we know that. We don't need a calculator for this. That's half. So half times 8 times 12 times half. Well, that gives us 6. That gives us 4. So this is going to be an area of 24 units squared. Okay. All right, let's go on to the next problem. Now, notice how we do know that the height of this triangle is technically 7. So if you wanted to just kind of go the shortcut route, you can say area equals half times base, which is technically 13, times 7. And if we do 13 times 7 and then divide that by 2, we'll get a value of 45.5. Okay. Now, just kind of linking that with what we've just talked about, though, you could also say that the area equals half times the base times, and then what we would need is a side length times sine of the given angle. I just want to show you that we actually do get the same answer. Alright, so just doing a little bit of math here. Since I know that there's 137 degrees there, and it is supplementary to 180, that means that this angle right here is 43 degrees. Okay, so if that's 43 degrees, I could find this hypotenuse by saying sine of 43 is opposite over hypotenuse, and so h is 7 over sine 43. On my calculator, when I do 7 divided by sine 43 degrees, I get a value of 10.26. Okay? So if that's 10.26, I could say area equals half times 13, the base, times side, which is 10.26, times sine of the included angle, which is 137 degrees. Okay? So if I enter that into my calculator, half times 13 times 10.26 times sine of 137 degrees, I also get the same answer of 45.5. Okay, so let's just kind of show you both ways in doing that. So the main idea that we have here in terms of getting the area of a triangle, its area equals half times the base of your triangle times a side of your triangle times sine of the included angle. Okay, that's our basic area of a triangle. Okay, you take the base times a side times sine of the included angle. You basically just need these three things to get the area of a triangle. Okay, all right. Let's do number 7 here. A triangle has an area of 10 centimeters squared and has sides of 6 and 9. So if we draw that out, we have a side of 6, we have a side of 9 centimeters. And the tricky thing about this is technically, I'm not quite sure what kind of triangle I have. Maybe it's 6 and 9 like that. Or maybe it's 6 and 9 like this. Right? Because if you think about it, yeah, this could be an area of 10. As this line goes up, if you just kind of imagine this line kind of goes up, then that area is going to increase, but at some point, once you get that right angle, then that area starts to decrease, because then you'll start to have a triangle more like this, right? The area gets smaller and smaller, so you'll have an area of 10 over here, and you'll also have an area of 10 over here. So we actually end up with 2 different scenarios, so you want to make sure you solve for both, okay? Well, what we know is that the area is equal to half times the base, okay, and then times a side times sine of the included angle. Well, if the area is 10, the area 10 equals half times the base, which we can call 9, times the included side, which is 6, times sine of the included angle. If we solve for sine of theta, let's multiply by 2, we get 20. Divide that by, let's just rewrite it, 20 over 9 times 6 is what, 54? Okay, or that's the same as 10 over 27. So we're saying sine of theta equals 10 over 27. Keep in mind that sine gives you a positive value in quadrant 1 and quadrant 2. So this is actually how we show that the angle gives us 2 different measurements, one that's acute and one that's also obtuse. Okay, so sine of theta is 10 over 27. Let's arcsine that in our calculator. Divided by 27. And we get that angle theta is a measure of 21.74 degrees. Oh, we have the acute angle. Let me write that in. This is the 21.74 degrees. Well, how do we find this one? We know that's just going to be its supplement, 180 minus 21.74 degrees. Okay, so 180 minus that answer will give us another angle measurement of 158.26 degrees. So those are going to be your 2 answers, 21.74 and 158.26 degrees. Okay, so that's what this question is asking for. Find all the possible measures for the included angle. Alright, one more question for you guys. Find the area of a regular 12-sided polygon inscribed in a circle. Inscribed means that it's inside. So just imagine that there's a 12-sided figure in here, like so. Okay, I'm not going to actually draw 12 sides, but you get the idea. And it has a radius of 8, which means if it has a radius of 8, that each of these will always be a value of 8. And if you notice, because it's a regular polygon, you'll notice that all these radii I'm drawing basically form triangles. They form isosceles triangles, to be more exact, a side of 8, a side of 8. The question is, what are the angles? Okay, so if we want to find the angles, we know a circle has a total of 360 degrees. How many triangles do you actually have in here? It's a 12-sided polygon. So take 360 degrees and divide that by 12. That's going to leave you with 30-degree angles in each of those triangles. So what you have is a side, angle, side. And from here, we can actually find the area of this triangle. If you just kind of tilt it, you'll know that this is 8, this is 8, this is 30 degrees. And now this is basically a problem just like problem number 5. Okay? So if you want to find the area of one triangle, you can just take half times the base, which is 8, times 8 times sine of the included angle, 30 degrees. Okay? Because that's how you can get the height of your triangle. So sine of 30, we know that to be half. Okay, so we're taking half times 8. That gives us 4 times another 4. That's going to give us an area of 16. Take that area of 16, and how many triangles do you have? You have 12 of them. So the area of 12 triangles is 12 times 16, and 12 times 16 is going to give us a value of 192 centimeters squared. Okay, so that'll do it for today's lesson. And you are good for area. On Tuesday, we'll resume the area notes and we'll be done with the chapter. All right, have a good weekend.